Welcome, my dear students of second secondary. Today's lesson is called the limit of the trigonometric function, and this lesson is given for scientific section only. Let's start. Limits of the trigonometric functions. Firstly, the rules. If x is the measure of an angle in radian, then limit when x tends to 0 of sine x over x equals 1. This is the first rule. The second one, limit when x tends to 0 of tan x over x equals 1. The third one, limit when x tends to 0 of x over sine x equals also 1. Sine x over x equals 1, then x over sine x equals also 1. Limit when x tends to 0 of x over tan x equals 1. Limit when x tends to 0 of sine x over x, here sine ax over x equals a. Limit when x tends to 0 of tan ax over x equals a. Limit of tan ax over bx equals a over b. And limit when x tends to 0 of bx over tan ax equals b over a. Example 1. Find the following limits. Limit when x tends to 0 of sine 2x over x. Without steps, without proof. Sine x over x equals 1. Then sine 2x over x, here the limit equals 2. Limit when x tends to 0 of tan 3x over 5x equals 3 over 5. Limit when x tends to 0 sine 2x over 5x. This value equals 2 over 5 directly. By using steps or proof, sine 2x over x, I'll divide both the numerator and denominator by x. Sine 2x over x and 5x over x. Sine 2x over x is this value. The limit of this value equals 2. Sine 5x over x, this value equals 5. Then the limit equals 2 over 5. And you can solve it directly. Sine 2x over 5x equals 2 over 5. Another problem. Limit when x tends to 0 of tan 3x over sine x over 3. Tan 3x over sine x over 3. This is 3 over third equals 9. We can solve this problem by using steps. 10, I'll divide both the numerator and denominator by x. Divided x divided x. Because the previous rules were tan 3x over x, tan ax over x, sine ax over x. Then tan 3x, I'll divide it by x. Also the denominator sine x over 3 over x. Here tan 3 over x equals 3. Sine x over 3 over x, the limit of this part equals third. 3 over third equals 9. Another problem. Limit when x tends to 0, sine x over 5 over tan 2x over 3. This is the limit of this part is 1 over 5 and the limit of the denominator is 2 over 3. Then 1 over 5 is divided by the fraction 2 over 3. Then the limit here equals 3 over 10. Another problem, tan 5x over 8x. Then this value equals, limit when x tends to 0 equals 5 over 8. Limit when x tends to 0 of sine 2 cubic root x over cubic root x. Here, this value cubic root x, and in the denominator cubic root x. This value like sine 2x over x. It's the same. Sine 2x over x equals 2. And the limit of sine 2 cubic root x over cubic root x equals 2. Another problem. Limit when x tends to 5 of sine x minus 5 over 3 x minus 5. Then this limit, x tends to 5, then x minus 5 tends to 0. If x tends to 5, then x minus 5 tends to 0. Sine x minus 5 over x minus 5, this value like sine x over x. Then the value of the limit equals 1 over 3. This value like limit when x tends to 0 of sine x over 3x. Sine x over x equals 1. 1 multiplied by 1 over 3 equals 1 over 3. Another problem. Limit when x tends to 0 of sine pi x over 6x. The same like sine ax over bx. This value like the rule limit when x tends to 0 of sine ax over bx. And the value of this limit equals a over b. Then sine pi x over 6x equals pi over 6. Limit when h tends to 0. Sine 3h squared over 4h squared equals 3 over 4. It's the same like this rule, sine ax over bx. Then the limit equals a over b. Sine h squared over h squared, then the limit equals 3 over 4. Another one. Limit when x tends to 0 of 3x squared over 10, 4. 3x power 5 over 10, 4x power 5. This is ax over 10 bx. Then the limit equals 3 over 4. Then the limit equals 3 over 4. This is like the rule limit when x tends to 0 of ax over tan bx. Here the limit equals a over b. Limit when x tends to 0, sine squared 5x over 2x squared. We can solve this problem by taking 1 over 2 as a separate fraction. Then sine 5x over x all power 2. Here I'll separate this algebraic fraction. I write 1 over 2, it's a limit. When x tends to 0, I write 1 over 2. Then sine squared over x squared, it can be written like sine 5x over x all squared. This is sine squared over x squared. Here, the value of the limit equals half multiplied by sine 5x over x equals 5. Don't forget power 2. Then this value equals 25. 5 power 2 equals 25 over 2. Another problem. Limit when x tends to 0 of sine x over 3 over 2x. Here, the same like sine. It's the same like sine ax over bx. As we write it before, the limit here equals a over b. Then sine x over 3 over 2x, here's the limit equal 1 over 3 third over 2, which equals 1 over 6. A over b equals a third. Here, a over b equals a third over 2 equals 1 over 6. Limit when x tends to 0, sine squared 5x over 7x squared. 1 over 7 multiplied by sine 5x over x, all raised to power 2, equals 1 over 7 multiplied by 5 squared equals 25 over 7. 1 over 7 multiplied by 5 squared, which equals 25 over 7. Again, another problem. Sine, limit when x tends to 0 of sine 5x squared over 7x. To solve this problem, to find the limit, take care. As we said, the previous rule, here is limit when x tends to 0, sine ax over bx equals a over b. To get the limit of algebraic fraction contains sine x or tan x. Take care. This value is x. Also, the value in the denominator should be written look like the value in the numerator. Here is x. Then the value in the denominator should be written as x. In problem number 15, the numerator contains x power 2, but the denominator contains only x. So you should multiply the denominator by x and the numerator also by x. To get the value of the denominator is 7x squared. I multiply both numerator and denominator by x. Here is x, also the denominator will be 7x squared. The value of the limit of sine 5x squared over 7x squared equals 5 over 7. The same like sine ax over bx, the limit equals a over b. Then sine 5x squared over 7x squared equals 5 over 7. And this fraction is multiplied by x. Here x equals 0. 0 multiplied by 5 over 7. The limit here equals 0. I'll solve it again. Limit when x tends to 0 of sine 5x squared over 7x. Here is x squared, here is x. Then I will multiply both the expressions by x. Then x sine 5x power 2 over 7x power 2. The limit in this part is 5 over 7. Don't forget to write x multiplied by 5 over 7. X here equals 0. Then 0 multiplied by 5 over 7. The limit here equals 0. Another problem. Limit when x tends to 0 of sine 2x multiplied by tan 3x over 4 x squared. I will separate this algebraic fraction. I write 1 over 4 multiplied by, remember the rule, sine ax over x, then x squared can be written as x multiplied by x. Then I write 1 over 4 multiplied by sine 2x over x multiplied by tan 3x over x. Here the denominator is 4x squared. 4x times x is 4x squared. Again, I will separate this fraction. I write 1 over 4, then sine 2x over x squared is separated into x multiplied by x. Then sine 2x over x, tan 3x over x. The result equals a quarter multiplied by sine 2x over x equals 2. And the tan 3x over x equals 3. Then quarter multiplied by 2 multiplied by 3. Then the value of the limit equals 3 over 2. Another problem. Limit when x tends to 0 of 3x cosec 2x. Here you should change the word cosec to its reciprocal. Then 3x multiplied by the reciprocal of cosec is sine. Then 3x multiplied by 1 over sine 2x. Then 3x over sine 2x. And the limit here, you can use the rule ax. You can use the rule limit when x tends to 0 of ax over sine bx, which equals a over b, 3 over 2. Another problem. Limit when x tends to 0 of sine 3x minus sine 2x over 5x. I'll separate as we did it before, I'll separate this algebraic fraction into 1 over 5 multiplied by sine 3x over x minus sine 2x over x. Here is 1 over 5 multiplied by sine 3x minus sine 2x over x, can be written as sine 3x over x minus sine 2x over x. This value equals the sine 3x minus sine 2x all over x. Then the limit will be 1 over 5 multiplied by, here is 3 minus sine 2x over x, is the limit equals 2. Then the value of the limit equals 1 over 5. Limit when x tends to 0 of sine x plus tan x over sine x equals. We can solve this problem by using the steps. You should divide both the numerator and denominator by x to write each term as the rule. Sine x over x, I'll divide both the numerator and denominator by x. Divided x is in divided x. Sine x over x plus tan x over x over sine x over x. Here, sine x over x equals 1 plus tan x over x equals 1. Sine x over x in the denominator equals 1. 1 plus 1, 2. Divided 1, the limit here equals 2. Thank you.